Assalamualaikum to Dr. Kairina. We are from Group 4. We'll be present about our group project, Finding Nearest Petrol Station using Digextra algorithm.
Imagine you are in a car trip alone, driving through unfamiliar areas, and suddenly your car full gauge is nearing empty. Then you start to panic and try to look for the shortest path to the gas station. However, this problem can be solved by calculating all the possible paths and take the shortest path. Based on the example of the graph representation, node A represents Bandar Malimau, B as Surkam, C as Asahan, and D as Bandar Jasin. The weightage for each node to node is shown in the graph. Hence, with all the information provided, what are the shortest path to the destination?
The jigsaw algorithm is a popular approach for determining the shortest path in a graph between any two nodes. It is frequently used for route planning in a transportation network. The jigsaw algorithm effectively determines the shortest path from a given location to the nearest petrol station by considering the petrol stations and their connections as nodes and edges in a graph respectively. The first step for jigsaw algorithm is the representation of the road network. The road network must first be labeled as a graph. Each road or edge between nodes in the network of roads indicates a link between two places, and each junction or node in the network of roads represent a location. Weights that correspond to the separation between the connected places are assigned to the edges. Next is creating the graph by specifying the nodes and edges. Then for initialization, set all other nodes to infinity and the starting point's distance to 0. For step 4 is shortest path calculation. Visit the unvisited node with the shortest possible distance starting from the beginning node and update the approximate distance between this node's neighboring node after making it as visited. The weight of the edge linking the current node to the neighboring node is added to the current node's distance to determine the updated distance. Update it if the new distance is less than the neighboring node's existing distance. Next, repeat step 4 until all nodes have been visited or the nearest petrol station is found. Then, backtracking from the petrol station node using the data saved throughout the algorithm's execution will yield the shortest path from the beginning to the petrol station. And the outcome, the algorithm calculates the distance and the shortest path between the starting point to the petrol station.
Then let's take a look at the source code. For the solution, the G-star algorithm will be used to find the shortest path in the weight graph. It initializes a distance map to store the shortest distance from the starting nodes to each node. Also, it initializes a path nodes map to keep track of the previous node in the shortest path. A priority queue is used to keep track of nodes and their distance during traversal. The algorithm starts by adding the starting nodes to the priority queue with a distance of 0. It explores level of the current nodes and updating their distance if a shorter path is found. The process continues until the destination node is reached and the shortest path is found. The map method demonstrates the usage of the digital shortest path by providing a sample graph, which is gas station routes, and finding the shortest path from the starting node A to the destination node D. The result, including the total distance and the nodes representing the shortest path, is printed.
Now, I will run the code to display the outcome solution. Okay, so in this output, it displays the shortest path from the starting nodes, which is Bandar Malimau, to the destination, which is a petrol station in Bandar Jasin, is 30 km. The calculation of the shortest path is involve the addition of weightage from road Bandar Malimau to Serkam to Bandar Jasin. Therefore, as we can see, in this path road, the Dijkstra algorithm has successfully found the shortest path to reach the destination. 30 km has been found after calculating from Bandar Malimau to Serkam 10 km and Serkam to Bandar Jasin 20 km, which is the destination where the petrol station is located.
In conclusion, Digistra's shortest path algorithm proves to be an efficient method for finding the nearest petrol station in a given road network. By employing a greedy approach and iteratively exploring the vertices with the lowest distance from the source, Digistra's algorithm ensures that the shortest path is discovered in the most time and cost-effective manner. Hence, this algorithm proves to be a valuable tool for making informed decisions and ensuring a seamless journey to the nearest refueling point.